Hello and welcome to a ramble. With me, we are rambling about IEB's May 2025 paper 2. We are today looking at question 11. Let us do it. So, in the diagram below, two circles are drawn. The equation of circle P is x squared plus y minus 1 squared is equal to 25. So that's this guy with center P, and from the equation we can see that the center has x coordinate 0 and y coordinate 1. So we know that the coordinates of P are 0, 1. And we also know that the radius is the square root of 25, so r is equal to 5, right? Good. Then the equation of circle Q, okay, so circle with center Q, is x minus 5 squared plus y minus 4 squared is equal to 9. So that tells us that the coordinates of Q are 5, 4, and the radius of this circle is the square root of 9, which is 3. Okay, good and well. Now, D and C are the points of intersection of the circles, so D and C. QD is a vertical tangent to the circle at D. Okay, so if we were to join Q and D, we're told that we would end up with a vertical, a vertical tangent. Okay, that is not a great, okay, but something like that. Right? Vertical tangent meaning that D's coordinates are going to be 5 and something. They have an x coordinate in common. Right. So then, last piece of information, if PQ bisects CD, if PQ bisects CD, determine the equation of the common chord CD. So let's just draw in these things that were being told here. So PQ bisects CD. Hey, that's not a great join. This is not working out in my favor. I think I must just surrender. So we're told that PQ bisects CD. Okay, and from Euclidean geometry, this is a line from the center bisecting a chord, meaning that they are perpendicular, right? That's one of the theorems from Euclidean geometry. I don't know if that's useful, but it might be useful, right? We are then asked to determine the equation of this chord that is common to both circles. It's in this circle and it's also in this circle, CD. Okay, lots of information. I won't lie, I'm not entirely sure where to start. Well, okay. So we know the coordinates of P and Q, right? And we know that this is perpendicular to this. Okay, so let me tell you where my mind went first, because now I just kind of started jumping into solving. My mind went to the idea that when we're looking for the equation of a line, we know that the equation of a line is y is equal to mx plus c. So the two key things we're after are m, the gradient, and c, the y-intercept of the line. So that's the m part is the first thing that came to mind because of this perpendicular relationship, right? If I know the gradient of this, then I can use the perpendicularness to figure out the gradient of that. So that's going to be the first thing I do. So, right, I'll start by saying the center of, well, the coordinates of P is 0 and 1, the coordinates of Q is 5 and 4, and that's based on the equations that we were given of the two circles, right? And so therefore the gradient of the line PQ would be 4 minus 1 divided by 5 minus 0, right? So that would be 3 over 5. And so therefore, well, okay, before we say therefore, we need to say that we know that PQ is perpendicular to CD, and that is because line from center bisecting chord. Look, I don't know if this is the official reason, but I feel like it summarizes all the important pieces of that theorem. So we know that the line from the center that bisects a chord is perpendicular to that chord. And so therefore, the gradient of CD will be equal to negative 5/3. That is the relationship of the gradients of perpendicular lines. Right. So therefore, the equation of CD will be something like y is equal to minus 5/3x plus c. Right, and then to find our c, as in the y-intercept, not the c, what stands out for me is that, okay, we've got half a clue about the coordinates of D. We've been told that the x-coordinate is 5. We don't know what the y-coordinate is. So I'm kind of looking at this PD and saying, you know, we know that it's 5 units long. So is that not something I can use to figure out the y-coordinate of D? I think I could. You know, if I set up an equation using the distance formula, I feel like I could. Another possibility is to solve simultaneously here, right? To figure out what are the points of intersection of these two. And then we would know that the solution where x is equal to 5, those are the coordinates for D. So that's another possibility. Also, oh my goodness, like why am I devastating myself? So D is on the circumference of this circle, the small circle, who has a radius of 3. So from Q to D is also going to be 3 units. We know that this is D is directly below Q, okay, because that's what they told us here. It's a vertical line, really. That's what we care about. And so, yeah, the coordinates of D are actually not hard at all to find. Oop, oop. So the coordinates of D are 5 and 4 minus 3. So the coordinates of D are 5, 1, right? 3 being the radius of the smaller circle. Excellent. And so now we can sub in this point to figure out this last piece. So sub into equation of CD. And so that would be 1 is equal to minus 5/3 times 5 plus C. I won't lie. These numbers are not making me feel warm and fuzzy inside, so I really hope that I have not messed up somewhere. But yeah, we've got 1 plus 25/3 is equal to C, and I think that's just then 28/3 is equal to C. And so therefore, the equation of CD would be y is equal to minus 5/3x plus 28/3. Right, so that would be my answer. How would I kind of do a sanity check? You know, how would I, if I had time in the exam, what could I do to kind of check and give myself confidence that, hey man, I might just be right? I think what immediately comes to mind is to just find the coordinates of the points of intersection, and then, you know, figure out the equation of the line that way. So let's see if we go that route. I'll do it in a different color, red, for confidence. So the first equation is x squared plus y minus 1 squared is equal to 25. The second equation is x minus 5 squared plus y minus 4 squared is equal to 9. Okay, I think those were the two. Let's just double check that. X squared plus y squared, y minus 1 squared is equal to 25. X minus 5 squared plus y minus 4 squared is equal to 9. So a general trick with solving simultaneous equations like these, so specifically finding the points of intersection between two circles, is the following. You expand each equation, well, the left hand side of each equation. So for the first equation, it would be x squared plus y squared minus 1y minus 1y, so minus 2y plus 1 is equal to 24, and then that would be x squared plus y squared minus 2y is equal to 23, right? So let's call that equation 3. And then from equation number 2, we would have x squared minus 10x plus 25 plus y squared minus 8y plus 16 is equal to 9. And then again, I'm going to move all my constants to one side just because OCD. So that would be 9 minus 25 minus 16, which just ends up being 9 minus 41, negative 32. Right. So the nice thing that we can do here is we can identify that there's an x squared plus y squared in this equation. There's also an x squared plus y squared in this equation, right? So using 3, we can then rewrite the equation as x squared plus y squared is equal to 23 plus 2y. So let's call that, okay, I don't think we need to call that 5. Just, this numbering is getting out of control. And then using 4, I can also isolate the x squared plus y squared terms, and then I would end up with negative 32 plus 10x plus 8y, right? If I move these guys over to the other side. And the power of doing this is that I can then say that 23 plus 2y must be equal to negative 32 plus 10x plus 8y. They must be the same because x squared plus y squared is equal to both of these expressions, right? So just like that, we've managed to kind of get the quadratic terms out of the picture, and we're kind of dealing with just the linear terms. And what I can then do is I can choose, okay, which variable do I want to express in terms of the other? So do I want to express x in terms of y or y in terms of x? And once I have that expression, I can then put it back into one of the original equations, and then my equation will just be in terms of x or just be in terms of y, and then I can solve. So that's the game plan. So in this case, I don't know, let's see, if I maybe I'll isolate the x just because 10, I don't know, is nicer to divide by, whereas look, it's just all discrimination. It makes no difference. You can choose whatever. I'll move all the y's to one side and everything else to the other, blah blah blah. So minus 8y on both sides, and then let's get the 23 onto this side. So then here we would have minus 6y is equal to minus 55 plus 10x, and then to get the y by itself, we would have y is equal to 55 over 6 minus, and this would just simplify to 5 over 3x, right? So there is an expression for y in terms of x, okay, that I'm going to call our equation number 5. So we can now take that and put it in here, right? So let us go ahead and do that. So sub 5 into 1, right? So that is what equation 1 looks like. We then replace, I actually should have, you know what? It's the same, whatever. I was going to say I should have made the x the subject so that this would be easier to work with, but it would have still probably been a two-term thing that I would have had to FOIL out anyway, so potato, potato. So we have 55 over 6 minus 5 over 3x minus 1 squared is equal to 25. So I'm just going to go ahead and simplify what's inside the bracket firstly. So 55 over 6 minus 6 over 6 is 49 over 6. Okay. And then we multiply out. Hi man, yo guys, which one is this one? Okay, and because this is a plus, we don't have to worry about signs too much, so I'm just immediately going to bust it out of the brackets. I want to square this. Yo, what am I doing? Where are my brackets? Yo, guys, can tell it is not an early hour of the night. Okay, you know what? Let's just so that is 2401 over 36, and then we have 49 over 6 times 5 over 3. So that is 245 over 18x minus another one of those, and then the last one would be 5 over 3x times 5 over 3x, well, and then negative times negative is positive, so that would be 25 over 9 x squared is equal to 25. She's Louise. Like terms, so x squared and another x squared term. This is 1x squared, which is just the same as 9 over 9. And if I add it to that, I end up with 34 over 9 x squared. And then my next set of like terms is the x terms here. Minus 245 over 18 minus another 245 over 18. So that's basically minus 2 times 245 over 18, right? So basically we can just cancel here. 2 goes into 18 9 times. So it's just the same as 245 over 9. And then the last guy does not have any friends per se. But as we can see, this is now a quadratic equation. So I might as well bring this guy over. Right? So let's just rewrite that. So 34 over 9x squared minus 245 over 9x. And then over here, I don't really know what the answer would be. So 2401 over 36 minus 25. So that gives us 1501 over 36 is equal to 0. Then, you know, we could multiply through by 36. 9 goes into 36, so then that would get rid of those denominators as well as this one. Blah blah, unfazed. Are we afraid of fractions? We are not afraid of fractions. So let's go ahead and just get into our big beautiful quadratic formula. So I'll start by writing it out. Right. So in this case, our b is minus 245 over 9. Put that there again. And then our a is 34 over 9. Our c is 1501 over 36. And then down here we have 2 times a again. Okay, so let's go ahead and sub all of that in. So we've got negative 245 over 9. Let's start with the plus. And then here we've got again negative 245 over 9 squared minus 4 times 34 over 9. Is this still inside the bracket? I hope so. It's outside. Oh no, it's always so finicky getting this right. Anyway, right, close the bracket, and then down here we have 2 times 34 over 9. And what do we get? We get 4,997 something something. Would be the x. Why is it not exactly 5? Because now we know that one of the points of intersection is going to be at 5. What are the, c can't be the 4.991. Let's see. If I do minus, who knows? We might be surprised. Yeah, you see now. So these would be the coordinates of C, the 2.2. Okay, so first let's just double check that we have inputted everything correctly, because that's the first way that we can break our hearts. So 245 over 9 minus 245 over 9, 34 over 9, 1501 over 36, 2 times. Okay, so everything is inputted correctly. So truly, I have made an error somewhere. So let's just go over everything one more time. So we said x squared plus y minus 1 squared is equal to 25. We expand. That expansion is correct. Why is it 24? Why is it 24? Why did it become 24? Who made him 24? Oh, what's that one? Okay, so this should have been 25. And then this should have been 24. Right? Okay, so here we were just expanding this. So this had to remain 25. And then we can minus 1 on both sides, and then it would become that is equal to 24. Might as well just double check everything, because can I even trust myself at this point? So expanding both of these, that expansion I agree with, x squared, okay, I'm not going to read it all out, and that one also makes sense, is equal to 9. And then we move our constants over, minus 25 minus 16. 9 minus 25 is minus 16, and minus another 16 is minus 32. So now using equation 3, which is actually it's 24, not 23. Oh, no wonder it's so close. Oh my goodness. Right. We actually end up with that. And then the second equation ends up being x squared plus y squared is equal to minus 32 plus 10x plus 8y. Happiness. So now we equate the two, right? So this must be equal to this because both of these are the same as x squared plus y squared. And then from there, okay, that's untidy. Whoa, right? From there, we minus 24 on both sides, okay. And then we minus the 8y on both sides, happiness. So this is minus 6y. This one would be minus 56, right? And 56 over 6 simplifies to 28 over 3, right? So y is equal to 28 over 3 minus 5 over 3x. Doesn't that look familiar? Doesn't that look familiar? Have a look at our solution. Y is equal to 28 over 3 minus 5 over 3x. Oh my goodness. Anyway, so that's a lot more promising. So then we sub it back into the first equation, which was that. So instead of 55 over 6 here, we have 28 over 3, right? So we replace the y with that, 28 over 3 minus 5 over 3x. 28 over 3 minus 1, which would just be 3 over 3. So that would be 28 over 3 minus 3 over 3, so that would be 25 over 3. And then we multiply out. So 25 over 3 times 25 over 3 is, what is 25 times 25? 25 times 25 is 3125, isn't it? Let's think about that. I shouldn't want to get my calculator out because I don't want to erase my beautiful quadratic formula there. 25 times 25. So let's just do that. So 5 times 5 is 25, times 5 is 125, times 5 is 625. Okay, so only if I were to times by 5 again would I get to 3,125. My bad. Right, so 25 over 3 times 25 over 3 is 625 over 9. And then 25 over 3 times minus 5 over 3. So let's just get rid of the highlighting for now. So that would be 125 over 9 minus another 125 over 9. And then minus 5 over 3 times minus 5 over 3 would still be 25 over 9 x squared. Right, so then these are our like terms again. So now we have minus 125 over 9 minus another 125 over 9, which is minus 250 over 9x. And then here we have x squared plus 25 over 9. Okay, so that's still true, 34 over 9x squared. And then the last one was this guy, who is not 2401 blah blah. It's actually 625 over 9. And then we minus this 25. So this term is still the same. This one changes. So this is now minus 250 over 9. And then this term also changes. So we have 625 over 9 minus 25. If I put, let's just quickly go here. If I want to write 25 as something over 9. What do I times? What's 9 times 25? 10 times 25 is 250, so 9 times 25 is 225. So this is 625 over 9 minus 225 over 9, so that is 400 over 9. Right, and this actually we can times through by 9, because all of them are, but again, we're not afraid of fractions, whatever. So this is now minus 250. This is also minus 250. This one doesn't change. This one changes to 400 over 9. And then over here we have 2 times a, which is still 34 over 9. Brilliant. So let's make our tweaks and hope that that does the trick. Okay, and then we said that this is another one that changes to 400 over 9, and now we get our wonderful, beautiful x. The one solution is that x is equal to 5, or the other solution would be, if we minus, x is equal to 40 over 17, which is about 2 comma something. Right, so that would be the x coordinate of c. So we know that the x coordinate of d is 5. The x coordinate of c would then be 40 over 17. And then we can work out the y coordinates by using this same expression that we found that connects x and y. Right, so sub x into this equation number 5 that we found, right? So, well, I'm going to duplicate it. Ugh. Come on. Okay, so when x is equal to 5, we have y is equal to 28 over 3 minus 5 over 3 times 5, which is equal to something I'm not going to work out myself. Oh wow, it's equal to 1. How underwhelming. Well, actually, we kind of saw that coming, right? We found that to be true when we were doing our calculations, right? So remember we said the y coordinate of d was 1 because it's 3 units below q. So voila, right? So that's the one solution. And then the other solution, when x is equal to 40 over 17, we have 28 over 3 minus 5 over 3 times 40 over 17. Right, and that is 92 over 17, and our calculator also shows us that this is roughly 5,41. Right, so what this is telling us is that if I were to just bring my diagram here, is this going to work? Maybe. Right, down you go. What this is telling us is that, let's bring out my zoomy zoom tool. The coordinates of C are 40 over 17 and 92 over 17, while the coordinates of D, are 5 and 1. And so we can figure out the equation of CD by working out the gradient and then subbing in one of the points to figure out thingy wingy. What is thingy wingy? Thingy wingy is the y-intercept. So let's quickly then work out the gradient of CD. So the gradient of CD would be 1 minus 92 over 17 divided by 5 minus 40 over 17. Right, which is what we got before. Nice, minus 5 over 3. So therefore, the equation of CD is something like y is equal to minus 5 over 3x plus c. And then we can sub in whatever point. For fun, we're going to sub in, let's sub in c. So sub in the point c. So we know that y is equal to 92 over 17, x is equal to 40 over 17. Right, so we have 92 over 17. Hey, where's my minus? There we go. So we can plus the 5 over 3 times 40 over 17 on this side. So let's see what we get. Oh, what is happening in the world? So we get C is equal to 28 over 3. And so the equation of CD is y is equal to minus 5 over 3x plus 28 over 3, which is what we got before. So that's what I would do if I had time in the exam to go through my answers. And this little nifty trick to find the point of intersection between two circles, where we expand each and then isolate the x squared plus y squared in order to equate these two, and then express the one variable in terms of the other, and then use that to replace it in any of the either of the original equations. That trick will always work for two circles, because the equation of a circle will always be x minus a squared plus y minus b squared. So whenever you multiply out those square brackets, you're always going to end up with an x squared plus y squared in both of the equations, which you can then eliminate. So that's a nifty thing to kind of keep in the back of your pocket, in your back pocket. Obviously you can see that it's a very hairy way to go about solving the problem. Like, I feel like we did a very good job of finding all sorts of little quick tricks to solve this problem efficiently. Like, there were little clues that we were given that sped the process up quite a bit. But, you know, if all fails, there's also that. So let's have a look at the memo. And we are in agreement with the memo. So that is that on that. And we will talk another time.